Hello everyone. Here let us see the next topic, multilayer perceptron. This is the third part of the artificial neural networks. So in the previous topic we have discussed about single layer perceptron, which was applied for linear separable data, but it was not applicable for non-linearity. So for example, we have taken XOR. So single layer perceptron was not applied for XOR input. So let us see how XOR can be solved by using multilayer perceptron. Thus, multilayer perceptron can be used for classification, which can implement non-linear discriminants. So this is the that is the data available for XOR, which is having inputs x1 and x2, and it is having an output. And here it is having an input layer and an output layer and an hidden layer. Okay, so here for neuron 1 it has an input as bias 1, for neuron 2 it has input of bias 2, and for neuron 3 it has input of bias 3. Additionally, neuron 1 has an input of x1 and as well x2, neuron 2 is having an input of x1 and x2, and neuron 3 is having an input of, which is an output of neuron 1 is an input for neuron 3, and output of neuron 2 is also an input for neuron 3. Okay, this is the activation function we have used. If the output is greater than 0, it is 1, otherwise it is 0. These are the weights initialized: W11, W12, W21, W22, W31. It is plus 1, W31 is minus 2, WB1 is weight is minus 1.5, W2, W3 weight is minus 0.5. Okay, the input is already given x1 and x2, and these are the weights initialized. So let us verify whether we are getting the correct output 0,1 from this neural network. 0,1 is the input and the output I should get as 1. From the neural network, let us verify it. So these are the weight. This is for neuron 1 and this is a neuron 2. Neuron 1, always remember, it's a burst bias will come and then inputs will come. The bias weight is for neuron 1 is B1. How much? Minus 1.5. And its weight is for x1 and x2 weight is how much? X1 and x2 weight, it is how much? It is W11 and W12, its weight is how much? Plus 1 and plus 1, 1, 1. This is for neuron 2. Neuron 2 bias is how much? Bias 2 weight is how much? Minus 0.5, minus 0.5. And its weight of x1 and x2, x1 and x2 weight is also 1, if you see here. So this is xn, that is the input. This is bias input. Bias input is what? 1. Okay. And now here 0, 1. Okay. It is a 0, 1. x1 and x2, it is 0, 1. Okay. Now, so let us see now how we can obtain. It is the same thing as explained in the previous video. It is a weight multiplied by the input and you have to perform an activation function. The weight, it's a transpose of weight into input. So here it's a multi-layer perceptron. So transpose is the main criteria here. So the weight and as well as input, perform the transpose. First perform the transpose. If it perform the transpose, you'll get like this, and this is the input. Multiply. After multiplying, you'll get, this is the output you'll get. And now if you apply this activation function, if it is greater than 0, then it is 1, less than 0 it is 0. Here it is less than 0, you are getting output as 0, greater than 0 you are getting it as 1. So here output of the first neuron is how much? 0. Output of the second neuron is what? 1. It is labeled as y1 and y2. y1 hidden layer, y2 hidden layer, y1 hidden layer, y2 hidden layer. Next, now we have to now process this neuron 3. So if you want to process the neuron 3, you can observe here. So here it is also same thing, we have to apply summation and the activation. So that is weight into input. So weight for this neuron 3 first. So it is a bias 3 weight, bias 3, then weight 3 1 and weight 3 2. And input is what? Bias input is what? 1, and its input is what? Output of these two. Output of these two is what? Y1 and Y2. Y1 and Y2. Now substitute the values. B3. What is the weight? B3 minus 0.5. Weight of what is that? 3,1 and 3,2. 3,1 is how much? Minus 2. 3,2 is how much? 3,2 is how much? 1. So how much you are getting here? Weight of 3, what is it? 3,1. 3,1 is what? Minus 2. 3,1. Weight of 3,1 is what? Minus 2. Okay. This is here. Okay. And 3,2 is what? Plus 1. 3,2 is what? Plus 1. So you are getting here. So here substitute and 1 bias input and Y1 and Y2. 0, 1. Substitute here 0, 1. So multiply, you are getting 0.5. Then apply the activation function. Greater than 0, it is 1. Greater than 0 is 1. Now for 0, 1, what is output you got from the final neuron 3 output? Neuron 3 output, how much you got? 1. What is the input I have given? 0, 1. How much is the output I have got? 1. Yes. Similarly, we have to do for other inputs. Okay. Thank you. And another point I have to highlight is, so here we got it now like this. For XOR, you can observe here 0, 1, it is 0. So 0, 1, it is 0. Okay. 0, 0, 0, 0, it is what? 0. Okay. So 0, 0, let me take it as 0. 0, 1, let me take as 1. Okay. Next 1, 0, it is what? 1. 1, 0, it is as, let me take it as 1. So here okay, so let me take 1, 1. 1, 1 as let me take into. Okay. So 1, 1 as input means like let me take the like this. Okay, these symbols let me take. So now as it is I have plotted. Okay. Now if you see, okay, so here I have taken 1, 1, 1, 1 as this symbol, 0, 0 as this symbol. That is, wherever zeros are there, into I have taken, and 1, 1 is there, I have taken this symbol, circle. So now can you apply a linear classifier? Yes. So what it does is, it will apply like this. By using a multi-layer perceptron, a linear classification can be done like this. So that is the solution which we obtain from the multi-layer perceptron. So here to build up this, there is a lot of equations directly you can take in this way where the classification can be done.